earthquakes and seismic waves. Now that we have talked about the layers of the earth, we are going to focus on how the earth shakes and earthquakes and seismic waves. So, with that being said, there is another assignment that is in week 8, and there is a PDF of this note presentation. There are several sections where you need to write in full sentences your observations, and in the end, a summary. So here is the slide presentation, and you'll notice that the words are highlighted in red. So follow along, and please fill out the notes, complete the summary, and submit them. So what are seismic waves, and how do they cause earthquakes? Earth's interior, earthquakes and seismic waves introduction. So this is a video that, if I can pull it into full screen.
Hey everyone, Jacqueline Howard here. Ever wonder what it's like inside our planet? Come with me on a subterranean tour all the way from the rocky crust where we live, through the layer known as the mantle, to the wild, half-solid, half-liquid core of the Earth. We'll also be stopping by a newly discovered underground ocean. Let's go! First stop, Earth's crust, the outermost layer where we live. The crust is made up of several elements, from iron to magnesium to sulfur, and its thickness ranges. The continental crust, the stuff found under land, can be up to around 50 miles thick, while the oceanic crust, the stuff found under our oceans, is around 4 miles thick. But let's see what lies below that. Now we're about 50 miles below the surface, at the uppermost region of the mantle. This layer is made up of rock that's rich in oxygen, iron, magnesium, aluminum, and it extends from here all the way down to around 1,800 miles below the surface. The mantle is also where molten rock known as magma can form, the stuff that flows upward during volcanic eruptions, at which point the magma becomes lava. This was pretty much the picture scientists had of the mantle until earlier this year, when a vast, hidden ocean of water was discovered some 400 miles beneath North America. It goes to show that the rocks down here have a pretty impressive capacity to store water. But now let's travel a little deeper. You ready? Here we are, 1,800 miles down at the Earth's outer core, which runs all the way down to around 3,000 miles. This is a layer of molten iron that surrounds Earth's inner core, and it's really, really hot down here. In fact, it's between 7,200 and 9,000 degrees Fahrenheit. But if you think that's scorching, wait until we reach the center of the Earth. And we made it to around 3,000 miles down, the uppermost part of the Earth's inner core. Like the outer core, it's made of mostly iron, but the pressure down here is so intense, the stuff is solid. It's almost incomprehensibly hot. It's about 11,000 degrees Fahrenheit down here. That's hotter than the surface of the sun. Now, the actual center of the Earth is about 4,000 miles down, but I'm starting to sweat, so let's skip that and head back up to the surface. Phew, back on the surface. If my virtual tour of the Earth's interior had been a real one, it would have been a first. We all know that no one's ventured beyond Earth's crust. But then, how do we know what's down there beyond the crust? Scientists use waves of energy called seismic waves emitted by earthquakes to measure what type of material is inside Earth and where that material lies. You see, as seismic waves travel through our planet, the rate in which they're traveling, whether they're moving fast or slow, reveals what exactly they're traveling through, whether that material's solid, liquid, or something else. Now you know. Leave your thoughts on what's lurking inside Earth in the comments, and come on!
Okay. So that's the video that brought you a little bit into our discussion of seismic waves. We have other videos as well. I'm going to escape out of this. And hopefully I can move to the next slide. I'll get better at this. And I don't know if I'll get better, but all right. So here, I want you to look closely at this picture. This is an earthquake that happened in Italy. And if you look to the left, here's the before and here's the after. So to give you an idea of how devastating earthquakes can be. I also want you to look here. This is in Alaska. And look at not just the highway was completely torn up, but look at the earth around it. This last was in Peru. It was in Chile. And if you look, you can see they lost a significant amount. Well, the road actually flipped over sideways because here are the cars laying sideways. So earthquakes can be extremely devastating. Looking at these 3 pictures, they are part of your notes. Look through them, and the next section I want you to do is to write in a full sentence. So 1 sentence here, a 2nd sentence there, and a 3rd sentence. 3 observations from the previous 3 slides, the earthquake images in the slides before. So go back, pause this recording right now, and go back and look at those 3 different earthquakes. There's one that has the before and the after, the Italy one, the one that happened in Alaska, and the one that happened in Chile. And write 3 different observations in your PDF. Okay, so now you're back. You've written your sentences. Where do the earthquakes occur? And this link over here is one that, oops, that's going to go back. That's not what I wanted. So this link is going to take us to the USGS earthquake tracking. So if we click here, this takes us to an interactive site that shows us the magnitude of a 2.5 in the past day. So I know that this isn't centered exactly. I'm going to zoom it out just a little bit, but you come over here and it's a GIS map. So you can click on it and it will tell you where it is, where this one is. I'm going to close that right there. So when we click on it, it highlights it. So there you are. That's in Nepal. This red right here is in Fiji. Over here, that is in San Antonio, Puerto Rico. Right there is actually in New Mexico in the United States. Up here, it's in Petrolia, California. Here is in Idaho. So we have earthquakes around the United States. Here's Alaska. So I'll tell you it's Dry Creek, Alaska. This is other areas here that show you this interactive. And this is updated continuously. Okay, so I'm going to escape from here, I hope. Maybe I'm not. Okay, so here we are tracking this. We're going to go to the next slide. What is an earthquake? So the definition is the shaking of the Earth's crust from the release of energy. It's as simple as that. An earthquake is the shaking of the Earth's crust from the release of energy. Stress, which is a force, builds up on either the rocks or the plate boundaries, and when the force of stress, is released, an earthquake occurs. This shows you the original position, the deformation that happens, and deformation means that it's changing and it's being bent or pushed or pulled. The rupture, the release of energy that's happening here, it's going in opposite directions. And this is what it looks like once the earthquake has stopped. So, in anatomy of an earthquake, the key topics that we need to know are fault, focus, epicenter, and seismic waves. These are terms that you're going to be hearing more and more about. The fault is the surface that the rock breaks through the earth. For example, throughout California all the way up to Alaska, there is a fault called the San Andreas Fault. Okay, that is the surface area that has fallen inward in the down into the towards the center of the earth. That area that used to be flat is now opening up like a crack. A focus is the source of the earthquake, so it's inside the earth. So it's the point inside the earth where the energy is released. The epicenter is the point on the surface directly above the focus. Seismic waves are energy waves that move out in all directions, 375-degree directions, and they cause the earth to shake. This is an example. Here is your focus. Within the earth, the epicenter is directly above it, and the fault is the crack. So you can see the fault scarp, or where this is the line because it cracks throughout the earth, but what we see on the top is something along this line. So the words we need to know are epicenter, which is directly above the focus, which is where the actual stress released. The focus is within the earth, and your fault is the line that it creates, that crack line. So here you're going to write down the letter that goes A, B, or C next to these three. Feel free to pause it. Okay, so now we're going to watch another very interesting discussion, and they call hypocenter, that is the focus, that is the European term of it, and they also talk about the body waves, which are within the earth, which are the P and the S waves, and then the surface waves as separate.
Seismic activity is also one of the most important sources of information about the interior of the Earth. In this video, we're going to read about the earthquakes. So what is an earthquake? It simply means shaking of the Earth. It is caused due to release of energy, which generates waves that travel in all directions. Now the question is, why does the Earth shake? To understand that, you'll have to look at this picture. This is a fault. A fault is a sharp break in the crustal rocks. Rocks near a fault tend to move in opposite directions. That creates friction, but at some point of time, their movements overcome the friction. As a result, they slide past one another. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake, or there is also a term given to it called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. This place is the first one to experience the waves. All natural earthquakes take place in the lithosphere. The lithosphere refers to the portion of depth up to 200 km from the surface of the Earth. An instrument called seismograph records the wave reaching the surface. The waves look something like this. The curve shows three distinct sections, each representing different types of wave patterns. We'll get back to this pattern in a moment. Earthquake waves are basically of two types, body waves and surface waves. I need you to understand the term body waves. Sounds a little larger within the body, right? So the body waves are generated due to the release of energy at the focus, that is the epicenter, and moves in all direction, traveling through the body of the Earth. It travels internally within the Earth's surface and moves the interior of the Earth. That's why it is referred to as body waves, because it is traveling through the body of the Earth like a tremor. Now it is obvious that when these body waves move towards the surface, they will come in contact with the surface rocks and generate new set of waves. These are called surface waves. Now the velocity of waves changes as they travel through materials with different densities. And we know that the materials with higher density recede downwards. Therefore, the denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. That's why when the seismic waves reach towards the surface of Earth, there the materials are of lower density, and that slows down the intensity of the waves, leaving behind a fault. Now going back to the picture that I showed you, so if you look at this picture, there are two types of body waves. They are called P and S waves. So the letter P and S stands for primary and secondary. Now you can relate when I say primary, they are the first one that gets recorded on a seismograph, the instrument, and then comes the secondary wave. You can look at this illustration to understand how these wave looks. The P wave, that is the primary or pressure wave, is a pulse of energy that travels quickly through the Earth's solid materials as well as liquids. It forces the ground to move backward and forward as it gets compressed and expanded. The S wave, that is the secondary or shear wave, follows more slowly with a swaying, rolling motion that shakes the ground back and forth perpendicular to the direction of the wave.
Perpendicular.
If at all the concept of P and S wave isn't clear to you, I recommend that you watch this video by Dr. Keith Miller, where he physically demonstrates P and S seismic waves. The video by him is extremely helpful. I'll link the video in the description and you can go and have a look at it. Now going back to this picture, after body wave, that is P and S waves, comes the surface waves. The surface waves are the last to report on seismograph. They look something like this. This wave spreads across the surface of the Earth. These waves are also more destructive and damaging. They cause displacement of rocks and hence the collapse of structures occurs. If you want to see more of such educational content.
Okay, so I'm going to escape out of that. Okay, and we will move to the next slide. All right, go back into presentation mode. All right, talking about, let's go back to this, I guess, body waves. The differences is between the arrival. So let me see if I can view and move in. I'll zoom to 200. Oh, that's too much. All right, sorry about this. I'll zoom back to the fit. All right, so it fits. All right, so here we are. I guess I can't really record this because it's too small. So body waves, seismic waves. P is for primary waves, which is what we went over in this video over here. They compress and stretch the rocks. So you see them going, compressing and then stretching the rocks. They're horizontal motion. So horizontal is, think of it as a table, flat. They move fast and they're the first to be detected. They travel through everything, solid, liquid, gas, plasma. The secondary waves, which is your S waves, look more like an S on its side, right? It moves vertically up and down, and it travels only through solids. Here's another example of your P wave, which are your body waves in motion. So if you pull this slinky type thing, it's going to expand. You let go, it's going to contract. So it's, again, horizontal, in and out. Wave is traveling, hand motion this way. That's your primary compression wave. Your secondary or shear wave is when you take a string and you go up and down. So it looks like an S on its side, right? Another S there, right? So your S. So it travels up and down, up and down. Shear wave, up and down. This is another video that shows you, I think it just shows you that they actually, what they look like. So there is your P and S wave, and now they've switched them. The S wave is on the top, but you can see the compressional wave of the P waves. So let's look at that one more time. There's your S wave. See how it's compressing in here? Okay. All right, so let's go to the next one. Your third type of wave, as he talked about, is your surface waves. So your L waves or surface waves are what we feel. They are created by the P and S waves when they reach the surface. They go in all directions. They are the slowest, but they're the most damaging. And if you can see, they kind of go in a curl kind of a motion. So these are your three types of earthquake waves. Your primary waves compress and stretch the rock. They move fast and first to be detected. They travel through all solid, liquid, gas, plasma. Your S waves, your secondary waves, move vertically up and down, and they travel only through solids. S, secondary solids. Your L wave, or your surface waves, and they are created by your primary and secondary waves. They reach the surface and they go in all directions. They are the slowest, but the most damaging. How do we know about the center of the Earth? Well, they talked about this in several different videos, and it has to do with seismic waves, particularly the S waves, and they're the most helpful. The reason the S waves are the most helpful is that they can only travel through solids. So you can see the S waves here where they get absorbed in this liquid outer core. Okay, so when they reach liquid, they're absorbed. So your shadow of your S zone is all the way from here to here. When you look at your P waves, they look pretty much the same, when you look at the solid, but when they hit the liquid, they refract and are bent. You can see how they're bent and they come out and they move back and forth. There is still a shadow on a P wave, but it's much smaller. Your S wave is, 2/3 of your whole sphere, and your P waves are very shallow on both sides. So to give you an example, here is the S wave. Again, the epicenter, the focus is below. It hits, here is your S wave shadow, okay? Here is your epicenter again at the top, at the surface, there is the focus. So here's your P waves, and when they hit the liquid, they bend, they change, and they come out. There's still a section where there's a P wave shadow, meaning no waves are recorded, but you can see how they do move through and they are changed and bent. Earthquakes and faults. What are the different types of faults that are caused by the plate tectonics? So, there are more than 1 million earthquakes annually. The largest earthquakes in modern history was in Chile, South America in 1960. It had a magnitude of 9.5 on the Richter scale. Some more facts about earthquakes. Most deaths occur in China. And the worst one was in 1556. There was 830,000 individuals that died. The largest in the United States was in 1964. It was a 9.2 magnitude, and it was in Alaska. Your most recent 3 that happened near Anchorage were back in 1999, and they were 4.5 to 5 magnitude. America has the lowest death rate. Why is this? Let's pause here and write some sentences and explain why. This one, I haven't given you the answer. This is where I'm asking you to be creative and to think it through. Why do we have the lowest death rate? Have we done something different? Could it be about our geology? Think about this and think it through and pause here and write a couple of sentences. Okay, so here we are. We're back with the Richter scale, and it ranks earthquakes based on ground movement. Intensity recorded on a seismometer, recordings are then called a seismograph. Each whole number, 1, 2, 3, etc., means an increase of 10 times the amount of ground movement. So this is what we mean when we talk about intensity. Here is an example of your Richter magnitude, 0 to 2. 8 and up is total destruction of building and bridges. You can see the different waves as they hit, and these are what an actual reading would look like. So there are 3 types of faults that occur. A normal fault, when the rock above the fault has moved down. It's caused by the tension or pulling forces, and they occur at divergent boundaries. You don't need to worry about that, just fill in the red at this point. We're going to talk more about faults when we get into plate tectonics. The second is a reverse fault. That's when the rock above the fault plane moves upward. It's caused by compression, which is a pushing force, and it occurs at convergent boundaries. The strike-slip fault is a fault where the movement is horizontal. It is called by shear force, and it occurs at transform boundaries. Here's an example. You can see the strike-slip fault. It's moving right next to each other. Here are faults in motion. This used to be attached up here. Right here again, these 2 used to be here. This one is moved down. This one is actually moved up. And here are some videos that show you, hopefully, yep, earthquake and shocks. So here you go.
Scientists until the development of plate tectonics theory in the 1960s.
Plate tectonics is the overall model.
We're going to pause on that because we're not at plate tectonics. I'm going to see if this one is going to be more helpful. Oh, this is insane footage. This one you'll probably like. Quake of 1989. This was their final warning. This is real footage.
Oh my God, we're having an earthquake. Wait a minute. Hold on. Can you feel that? Okay, this is interesting. There go the lights. Oh.
Uh-oh. Okay. So we'll come more and we'll come back to this. Right now, what I'd like to do is I would like to have you write your summary in 5 to 6 full sentences. Look back through your slides, write down what you've learned, use your vocabulary. And once you're done, save it in your drive and submit it into Schoology and have a great weekend.